Have we reached a point where the silicon-based cognitive architecture will surpass the ancestral biological neural networks of humanity? Welcome to our deep investigation into the fifth most influential event ever documented in the historical annals of humanity. This extensive 20-minute documentary will provide an exhaustive technical analysis of the algorithmic revolution currently transforming our world. Theoretical foundations were established in the mid-20th century when scholars began envisioning electronic systems capable of autonomous logical deduction. These early researchers sought to replicate human thought processes using complex mathematical frameworks and discrete computational architectures. The intellectual center of this movement emerged in the northern academic hubs, where visionary professors collaborated on the first neural simulations. Technological clusters developed rapidly as government funding accelerated the construction of massive mainframe facilities dedicated to data processing. Initial programming methodologies relied on symbolic logic, where every decision path was explicitly defined by human engineers through exhaustive code bases. Heuristic search algorithms allowed these early machines to solve complex puzzles and perform basic linguistic translations with increasing accuracy over time. The 1980s introduced the concept of backpropagation, which enabled multi-layered networks to learn from statistical patterns within huge datasets. Global transistor density increased exponentially according to industrial observations as manufacturing techniques reached the nanometer scale by the early 21st century. Corporations began investing hundreds of billions of dollars annually to integrate algorithmic efficiency into every segment of the industrial manufacturing process. We observe the proliferation of high-frequency trading systems that execute financial transactions with millisecond precision based on predictive market analysis. Medical professionals now utilize diagnostic tools that analyze radiological images with 99% accuracy across various complex pathological cases. Urban infrastructure is being optimized through intelligent ecosystems that manage energy consumption and traffic flow to minimize environmental degradation significantly. Educational institutions are adapting their curricula to focus on digital literacy as automation transforms the traditional landscape of human labor globally. Autonomous vehicles process petabytes of sensory data every millisecond to navigate complex urban environments with unprecedented safety for all passengers involved. The integration of genomic sequencing with synthetic intelligence allows for personalized medical treatments tailored to the specific biological markers of individual patients. Large-scale language architectures facilitate instantaneous translation across hundreds of linguistic barriers previously considered insurmountable by traditional methods. Sustainable energy grids utilize predictive algorithms to balance intermittent supply with fluctuating demand across vast continental distributions of electricity. Precision agriculture relies on algorithmic monitoring of soil health and crop growth to maximize yields while minimizing chemical interventions in farming. The evolution of tactile robotics enables machines to perform delicate surgical procedures with a level of steadiness and precision exceeding human capability. Economic reports indicate that artificial intelligence could potentially contribute over $15 trillion to the global economy within the current decade. Global computing networks now function as the primary circulatory system for our modern data-driven civilization's collective intelligence and knowledge storage. Robotics laboratories continue to push the boundaries of mechanical dexterity and cognitive integration for real-world industrial and domestic applications. The manufacturing of advanced processing units requires ultra-clean environments where specialized technicians oversee the fabrication of billions of microscopic circuit components. Technological hubs like Shenzhen demonstrate the massive scale of urban integration where digital systems monitor and manage every aspect of metropolitan life. Fiber optic infrastructure facilitates the near instantaneous transmission of petabytes of information across continental divides and deep-sea telecommunication cables. The London Financial District serves as a critical junction where algorithmic trading strategies determine market stability and global resource distribution. The period known as the First Artificial Intelligence Winter resulted from the limitations of symbolic systems to handle real-world ambiguity and noise. Government research agencies significantly reduced financial allocations as early optimistic predictions regarding machine translation failed to manifest within the expected time frame. Scholars began exploring alternative paradigms that emphasized statistical learning over the rigid structures of purely logical and symbolic expert architectures. The resurgence of connectionist theories provided a vital spark for the development of multi-layered networks capable of identifying patterns in raw sensory data. Computational scientists discovered that increasing the number of hidden layers within a network allowed for the extraction of highly abstract features. Refinements in backpropagation algorithms permitted the efficient adjustment of millions of internal weights to minimize the error margin during training phases. Modern manufacturing facilities integrate hundreds of automated units that communicate through low-latency networks to optimize production throughput and resource efficiency. Technicians in sterile environments monitor the fabrication of advanced semiconductors that serve as the physical foundation for all contemporary intelligence systems. Submarine cables spanning thousands of kilometers across ocean floors provide the necessary connectivity for the global exchange of massive informational datasets. Massive server farms consuming megawatts of electricity operate continuously to process the ever-growing volume of digital transactions and algorithmic computations. The industrial landscape of Shenzhen represents a critical nexus where rapid prototyping and large-scale hardware manufacturing accelerate the pace of technological adoption. Advanced computational models analyze trillions of data points within the Canary Wharf financial hub to predict global market shifts with extreme granularity. The continuous flow of metropolitan commuters provides a complex behavioral dataset used to train the next generation of urban management algorithms. The production of high-purity silicon crystals requires extreme thermal stability to ensure the reliability of microscopic semiconductor architectures. State-of-the-art photolithography systems utilize deep ultraviolet light to etch billions of transistors onto a single square centimeter of silicon. Robotic platforms operating within sterile environments facilitate the damage-free transport of fragile wafers between different stages of the manufacturing cycle. Intercontinental telecommunication is supported by undersea cabling networks that utilize optical amplification to maintain signal integrity over thousands of miles. Visualizing the multidimensional layers of a neural network reveals the hierarchical nature of how information is processed and abstracted by modern machines. Game-playing algorithms demonstrate remarkable strategic depth by evaluating millions of potential moves per second to identify the optimal winning trajectory. Benchmarking the performance of advanced chess engines provides vital insights into the efficiency of search heuristics and positional evaluation functions. Integrated sensor feedback loops allow industrial robots to adapt their movements in real time to changing physical conditions on the production floor. Research laboratories focus on the co-optimization of specialized hardware and software to minimize the energy consumption of large-scale training workloads. Autonomous vehicles leverage high-bandwidth telemetry processing to fuse data from LiDAR, radar, and vision systems into a coherent environmental map. Robotic surgical systems provide surgeons with enhanced dexterity and tremor filtering to perform delicate maneuvers within extremely confined anatomical spaces. Automated radiological diagnostic tools assist medical professionals by highlighting areas of concern within high-resolution tomographic imagery with superior consistency. Metropolitan traffic management systems utilize real-time behavioral heuristics to dynamically adjust signal timings and reduce congestion across entire city blocks. Innovative thermal management solutions are essential for maintaining the operational stability of high-density server racks within global data centers. Maintaining data consistency across geographically distributed databases requires sophisticated consensus protocols that operate at the speed of light. Analyzing the convergence properties of generative adversarial networks is crucial for producing high-fidelity synthetic content with predictable aesthetic characteristics. Modern diffusion models utilize iterative noise reduction techniques to synthesize coherent visual structures from purely stochastic initial conditions. Industrial yield enhancement programs leverage machine vision to identify microscopic defects during the complex multi-stage fabrication of advanced microchips. Integrating automated defect detection systems into the wafer production line significantly reduces the time required for comprehensive quality assurance testing. As transistors reach the atomic scale, engineers must develop innovative mitigation strategies to manage the effects of quantum tunneling on processor performance. Enforcing strict safety and contamination protocols within high-tech laboratories is paramount for ensuring the integrity of sensitive technological research. The connectivity infrastructure of Shenzhen facilitates the rapid exchange of technical knowledge and manufacturing resources within the world's leading hardware ecosystem. Predictive analytics models monitor global financial liquidity to provide early warning signals of potential systemic risks within the international banking network. Establishing comprehensive audit frameworks for algorithmic governance is essential for maintaining public trust in the automated systems used by civil institutions. Identifying and neutralizing biases within large-scale training sets is a fundamental challenge for the development of fair and equitable machine learning models. Deploying advanced cryptographic protocols allows for the secure processing of private information without compromising the confidentiality of individual user data. Economic modeling studies suggest that the widespread adoption of intelligent tools will fundamentally alter the traditional relationship between human labor and capital. Global research initiatives focus on aligning the long-term goals of general intelligence systems with the ethical values and safety requirements of human civilization. Automated workload distribution algorithms balance processing tasks across thousands of physical servers to ensure consistent performance for global users. Human-robot collaboration in research environments accelerates the discovery of new materials and chemical compounds for sustainable energy storage. The precision required for high-purity semiconductor fabrication necessitates the use of advanced atmospheric control systems within the manufacturing plant. Strategic geographical positioning allows innovation hubs like Shenzhen to integrate specialized manufacturing expertise with global logistics networks. High-speed data transmission through terrestrial fiber networks supports the real-time operation of decentralized autonomous organizations across multiple continents. The dominance of algorithmic modeling in global finance has fundamentally altered the mechanisms of price discovery and capital allocation in modern markets. Machine learning models trained on vast quantities of mobility data enable the optimization of public transportation networks for millions of daily commuters. Modern industrial facilities leverage computer-integrated manufacturing to achieve unprecedented levels of repeatability and quality in complex product assembly. Clinical decision support systems provide healthcare professionals with evidence-based recommendations derived from the analysis of millions of historical patient records. Enhanced visualization tools integrated into surgical platforms allow for the identification of critical anatomical structures with sub-millimeter precision. Integration of environmental sensors into metropolitan infrastructure provides the granular data necessary for managing the complex energy demands of smart cities. High-performance computing clusters operating within specialized data centers provide the massive throughput required for training billion-parameter linguistic models. Real-time analysis of network traffic patterns allows for the dynamic rerouting of informational packets to avoid congestion in global telecommunications. The expansion of high-bandwidth optical transmission infrastructure is essential for supporting the growing demand for cloud-based artificial intelligence services. Neural processing architectures designed specifically for generative tasks allow for the rapid synthesis of complex visual and auditory content from textual prompts. Progressive refinement techniques used in diffusion-based synthesis produce coherent results through the iterative reduction of Gaussian noise from initial states. Automated control systems within advanced cleanrooms monitor thousands of environmental variables to ensure the reliability of the microchip manufacturing process. Advanced wafer lithography techniques utilize short wavelength radiation to define the extremely small features required for modern high-performance microprocessors. Standardized benchmarking protocols allow researchers to objectively evaluate the performance of diverse machine learning models across a wide range of tasks. The integration of real-time economic data into predictive models provides policymakers with vital insights into the evolving landscape of global industrial activity. Secure exchange of sensitive information is facilitated by advanced cryptographic architectures that protect individual privacy in an increasingly connected world. Shifts in urban labor markets are driven by the adoption of intelligent tools that automate routine tasks while creating new opportunities for problem solving. Exploring the future horizon of technological development reveals the profound potential for synthetic intelligence to enhance the cognitive capabilities of our species. Managing the complexity of modern integrated circuits requires the use of sophisticated electronic design automation tools to verify architectural integrity. Strict adherence to sterile laboratory protocols is essential for preventing the contamination of sensitive semiconductor components during the fabrication cycle. The robustness of the Shenzhen technological ecosystem is supported by a dense network of specialized suppliers and rapid prototyping facilities. Yield management logic utilized in semiconductor manufacturing identifies the root causes of production errors to continuously improve the efficiency of the factory. Automated inspection systems employ high-resolution vision to detect microscopic anomalies in silicon wafers before they are packaged into final processor units. Foundational logical principles established during the early era of computing remain relevant for the design of modern high-level programming languages. Hardware prototyping laboratories facilitate the rapid iteration and testing of new architectural concepts for specialized artificial intelligence accelerators. Maintaining data integrity across decentralized networks requires advanced consensus protocols that operate with sub-millisecond latency. Intelligent fleet management systems utilize real-time telemetry to optimize the routing of autonomous vehicles across complex logistics networks. High-throughput sequencing architectures leverage parallel processing to identify critical genetic markers with unprecedented statistical confidence. Remote surgical platforms integrate high-bandwidth data streams to provide surgeons with real-time haptic feedback during complex medical procedures. Dynamic load balancing heuristics manage the fluctuating energy demands of modern urban ecosystems to ensure maximum grid stability and efficiency. Advanced quality assurance metrics utilize high-resolution imaging to verify the geometric accuracy of complex industrial components during assembly. Optimizing global supply chains requires the integration of real-time industrial data with predictive models to manage logistical risks effectively. Optical signal amplification infrastructure is critical for maintaining the high-speed data flow required by modern decentralized computing clusters. Neural architecture search algorithms automate the discovery of efficient model structures for specific computational tasks in high-performance computing labs. Advanced heat dissipation technologies are essential for maintaining the operational longevity of high-density processors within modern industrial hardware. Achieving sub-micron resolution in photolithography requires the use of specialized short-wavelength radiation and high-precision optical alignment systems. Market sentiment analysis frameworks process vast quantities of linguistic data to identify emerging trends and manage financial risks in real time. Implementing secure multi-party computation protocols allows for the collaborative analysis of private datasets without compromising individual confidentiality. Predictive metrics for sustainable urban development utilize sensor data to optimize the allocation of municipal resources and reduce environmental impact. Analyzing the stability of model convergence during large-scale training is vital for ensuring the reliability of contemporary deep learning architectures. Sophisticated trajectory planning heuristics allow autonomous robotic arms to navigate complex work environments with high levels of mechanical precision. Efficient data transmission protocols are fundamental for supporting the massive informational throughput of modern global telecommunications networks. Large-scale inference processing speed is a critical performance metric for the real-time deployment of advanced synthetic intelligence services. Verification logic for microscopic circuit patterns identifies potential manufacturing defects before final silicon wafers are prepared for packaging. Metrics for industrial supply chain resilience provide vital insights into the stability of global manufacturing hubs during periods of disruption. Ensuring compliance with advanced cleanroom safety protocols is essential for maintaining the high yields required in modern microprocessor fabrication. Optimizing trading engine latency is paramount for maintaining competitive advantage within the high-frequency environments of international financial markets. Analyzing commuter pathing heuristics allows for the dynamic optimization of urban transportation systems to reduce travel times for city residents. Precision analysis of tactile feedback systems is crucial for developing robots capable of performing high-sensitivity tasks in delicate environments. Verification logic for medical diagnostic tools ensures that predictive algorithms maintain high levels of accuracy across diverse patient populations. Real-time congestion mitigation loops dynamically adjust municipal traffic signals to improve the overall efficiency of urban mobility networks. Analyzing power consumption efficiency metrics is essential for reducing the environmental footprint of large-scale global computing infrastructures. Deploying secure cloud infrastructure requires the use of advanced encryption protocols to maintain the integrity and confidentiality of processed data. Diversity metrics for large-scale training datasets are fundamental for ensuring the fairness and equitable performance of synthetic intelligence models. Analyzing stability control heuristics for smart grids is critical for managing the complex energy distribution requirements of modern cities. Benchmark analysis of high-performance hardware throughput provides vital data for the selection of optimal architectures for specific AI workloads. Maintaining signal integrity in advanced optical fiber transmission is essential for supporting high-bandwidth global data communications infrastructure. Studying task parallelization efficiency metrics allows researchers to optimize generative architectures for rapid synthesis across diverse media formats. Analyzing noise reduction iteration logic is fundamental for improving the fidelity and aesthetic consistency of diffusion-based synthetic content. Studying resolution enhancement techniques for industrial lithography is vital for the continued scaling of microscopic microprocessor architectures. Market liquidity risk assessment frameworks leverage predictive analytics to identify potential systemic vulnerabilities in the international banking system. Audit logic for algorithmic governance protocols ensures that automated systems used by civil institutions operate with transparency and accountability. Analyzing the efficiency of bias mitigation strategies is crucial for developing equitable and fair synthetic intelligence models for global deployment. Studying the deployment logic for secure multi-party computation protocols allows for the collaborative analysis of private information while maintaining confidentiality. Analyzing the modeling logic for economic productivity transformation provides insights into the evolving relationship between human capital and automation. Researching safety alignment logic frameworks is fundamental for ensuring the beneficial and ethical long-term development of general intelligence systems. Studying the design logic for architectural integrity verification protocols is essential for maintaining the high reliability of modern microprocessors. Analyzing the logic for contamination control adherence metrics ensures that high-tech laboratories maintain the sterile environments required for sensitive research. Studying the logic for ecosystem robustness metrics provides vital insights into the stability of specialized global supplier networks for technology. Developing the logic for yield optimization strategy analysis frameworks is crucial for continuously improving the efficiency of semiconductor manufacturing processes globally. Reflecting upon this technological odyssey reveals a future where the boundaries between biological and synthetic intelligence continue to dissolve rapidly. The task of guiding this profound power remains with the collective wisdom and ethical considerations of the global community of humans. Thank you for accompanying us through this exhaustive examination of the fifth most pivotal milestone in our shared historical journey. 구독과 좋아요를 눌러주세요. 감사합니다.